Hello class, welcome back to week 2 videos of Math 110. This is part 2. We're going to continue on with section 2.3. This is number 51. This is an investment problem. So there's a couple different ways to do these types of problems. For now, in section 2.3, we haven't got to systems of equations yet. So we'll be working these without the use of systems of equations, which means we're going to try to work these problems with only one variable and not two variables. So let's go ahead and start this one. I've made a little box that sort of makes this a little easier to work with. Your book sets it up this way as well, so you may want to check those examples out. They should be similar. Okay, so we're working with a box where we have the amount invested and we have the rate. So if we take these two and we multiply them, that will tell us the interest for 1 year. So we have principal equals interest times rate times time. So we have the amount invested, which is the I, the rate, which is the R. Now T is just 1 since we're only working with 1 year for these. So that's why we can do this. Okay, so Jennifer invested some money. Okay, so some money. This is an unknown amount. This is considered a variable. So she invested some money at 4.5%. Okay, so the amount invested, we don't know. So that's a variable, or an x. And we do know the rate, which is 4.5%. When we're working these, we do want to take our percent and turn it into a decimal. So we're going to slide it twice to the left. So that's going to give me 0.045. Okay, so that's the first investment. And $1,000 less than twice this amount. Again, this amount is the unknown value. So $1,000 less than means we're subtracting $1,000 from twice this amount. Well, again, we don't know what this amount is, so that's our x. And it's invested at 3%, which again, we move the decimal to give us 0.03. Okay. So when we multiply these together, this is going to tell us how much interest we've earned for 1 year. So I'm going to take x times 0.045 or 0.045x. So this is how much interest we're going to earn in 1 year if we know the amount invested. On the bottom, we have 0.03. Now I'm going to multiply it by this 2x minus 1,000. We would have to find this amount first before we multiply it by the 3%. So what we do is we put it in parentheses. Okay. Now let's see what other information we have. Okay. Her total annual income from the interest was $1,020. So total, that's telling us that this is equal to, when we add these two, it's equal to the $1,020. So that tells me how to set up my equation. It tells me that if I take this interest plus this interest, it should equal the 1,020. So I have the 0.045x plus the 0.03 times 2x minus 1,000 should equal the total amount earned off the interest. And now we are solving the equation. So we're going to go ahead and distribute. So we have 0.045x plus 0.06x minus 30. So if you need a calculator to work those, feel free to pause and calculate them out. We have some like terms over here on the left side, so we're going to go ahead and add those. So that gives us 0.105x. The minus 30 equals 1,020. Now I go ahead and I want to move the 30 over, so I'm going to add it over since the opposite of subtraction is addition. And we have 0.105x equals 1050. And then divide by 0.105, divide by 0.105. And again, if you need to use a calculator, you can. And that should generate 10,000 for us. Now, what is this 10,000 that we just found? This is the amount that's invested at the X. So if we go back up to our chart, X is the 4.5%. So this is telling me that I invested 10,000 at 4.5%. To figure out how much was invested at 3%, we need to go and figure out, well, we know it is 1,000 less than twice this amount. So off to the side, we have 2x minus 1,000. And we know that x is 10,000, so we put that in. So 2 times 10,000 minus 1,000. And we get 20,000 minus 1,000. And that gives me 19,000. So we invested 19,000 at the 3%. So we wanted to find the investment at each. So again, I would suggest making the little table there to get it set up and working your way through. Right, let's continue on with section 2.3. Okay, so we're going to work on another problem, number 61 in 2.3. And this is dealing with Randall wants to mix 50 pounds of nuts worth $2 per pound with some nuts worth $6 per pound to make a mixture worth $5 per pound. How many pounds of $6 nuts must he use? Okay. So our little chart that we're going to set up, we have two things going on. We have pounds and we have dollars. So we have pounds and we have dollars. Now, what ends up happening is if we had 50 pounds of the first mixture and it was worth $2 per pound, well, when I multiply these two, that should give me the total cost for just that mixture. Okay, so we're dealing with the first mixture. We have 50 pounds. It's worth $2 per pound. So if we take 50 times 2, that's $100. The second mixture we have some nuts. So that's pounds. Don't know how many we have. We do know the price, which is $6. Again, if we multiply these together, that would give us the total cost for just those nuts. Now the last one we have is we want to make a mixture worth $5 per pound. Okay. So we're going to take these two and add them together, and that should give us the total number of pounds. So we're creating a mixture here. We're taking the $2 and the $6, mixing them together to give us the $5 pounds. So that means if I have 50 plus the X, that will tell me how many pounds I have left over at the very end. Okay, so if we knew it was 50 pounds at $2 and 10 pounds at $6, well, 50 plus 10 would give us a total of 60 pounds for the whole thing. We don't know how much for the 6, so we just keep the X there. So when I multiply these two, I get 5 times 50 plus X. So the idea is just like these two, we're adding them together to equal this bottom one. Same thing here. We're going to take the cost of the first one plus the cost of the second one, and it should equal the cost of the entire thing, the mixture. So we have 100 plus 6x should equal 5 times 50 plus x. And again, we're solving. So go ahead and distribute. And we have 100 plus 6x equals 250 plus 5x. Bring the 5x over. And we have 100 plus x equals 250. And then bring the 100 over. And we have x equals 150. Now remember, x is the number of pounds for $6. So this is 150 pounds that we found. And it's asking us how many pounds of $6. Well, we found exactly what we need. We don't have to plug it into anything. So we have 150. All right, let's look at another one in this section. Or sorry, this one's going to be in 2.4. We're bumping to the next section. They're very similar, 2.3 and 2.4. Okay, so we're dealing with coins. And we have two things going on. We have the number of coins, which is 41, and then we also have the dollar amount. So let's go ahead and look at setting up a little chart for this one like we have been working. Okay, so we have the number of coins is one thing that we have going on, and we have the dollar or denomination. And then if we know how many coins, if we had 5 coins and they were 25 cents each, we could take 5 times 25. That will give us the total. Okay, that gives us how much those coins are worth. Okay, so let's see what we have. Well, it says that Dave collects U.S. gold coins. He has a collection of 41 coins. Some are $10 and the rest are 20. So I know some are 10, some are $20. And I know that the face value of the coins is 540. So that's going to be my total is 540. So we just need to figure out how many of each we have. But we know there's a total of 41. Okay. I don't know how many are at X. Or sorry, at $10. So I can call that X. That's an unknown value. We don't know how many are there. Now the second one is also an unknown value, but there is a way of finding out how many there is. So if we knew we had 15 here at the $10, well, I would just take 41 minus 15. That would tell me how many I have left over. That would have to be the 20. Well, same concept goes when you have the variable. If we want to know how many are left over, we're just going to take the total and subtract off whatever was used at the $10. We don't know the exact amount, so we call it X. So we multiply these together, and that gives us 10x, and this gives us 20 times 41 minus x. So we have the total amount for the $10 coins, the total amount for the $20 coins, and we know they should equal. So again, this is adding these together. So we have 10x plus 20 times 41 minus x. should equal 540. And now we go ahead and solve. So we get 10x plus 20 times 41 is 820. That's an 8. Minus 20x equals 540. Combine your like terms. 10x minus 20x gives me negative 10x plus 820 equals 540. Subtract the 820. And that gives me negative 10x equals negative 280. And divide by negative 10. And we have x equals 28. So remember, x is the number of coins at $10. So this is the number of coins at $10. So we have 28 coins at $10. The other one is 41 minus x. So my second part is now take 41 minus x. Well, we know x is 28. So 41 minus 28. And that gives us 13. And this is for the $20. So this is at $20 coins. So these problems are similar, setting up the boxes, looking at how to multiply them together. Once you get that box under control, it should go a little quicker for you. So I would suggest taking some time to learn how to make those boxes and use those to help you work your problems. All right, let's look at one more on section 2.4. So in section 2.4, number 21, we're going to look at. And this is dealing with streamers. So we have them leaving a port on a river at the same time, traveling in opposite directions. Each is traveling 22 miles per hour. How long will it take for them to be 110 miles apart? Okay, so the idea is we have two leaving the same spot. So they're in a spot, one's heading this direction, one's heading this direction. They left at the same time. They're traveling the same miles per hour. So that means that their distances are going to be the same. Let's see what that does for us. So we have d equals r times t. Distance equals the rate times the time. So we have a rate for the first one is 22. Rate for the second one is 22. Okay, it told us that both of the rates were 22. Now it tells us time. Well, it doesn't tell us the time. It tells us they leave at the same time. So that means both of these are unknown, but they're both the same. Well, to figure out the distance, if I know how fast they're going, I just have to multiply the time. That's what our formula is. So distance is these two multiplied together should equal the distance. So I have 22t, 22t, and I know the total distance apart is the 110. So again, these are traveling the same rate. They're traveling for the same amount of time. So that means that the distances are the same. And it means if I have the total, all I need to do is add these two, and it should equal that total. So 22t plus 22t should equal 110. Combine like terms, 44t equals 110, and divide by 44. And that gives us t equals 2.5. And this is talking about time, and we're in hours since we're dealing with miles per hour. Okay, so that finishes up part 2 of the videos. Come back for part 3. We're going to go over section 2.5, 2.6, and 2.7. We'll get into solving inequalities and absolute value equations. So see you in see you in part 3.